Right, so what we have is a standard maximization problem, but this time it has 3 variables in it. So now we're getting into the problems where we couldn't use the graphical method before. So we have here maximize z equals 4x1 plus 3x2 plus 6x3, and we have 2 constraints, and as always, the non-negativity constraints. So just to warn you about the format of this video, I already have some of the steps pre-done, so that I'm gonna outline what to do, and then what you can do is just pause the video, work it out, come back, check your answer, and I assure you that my answer will be correct, I hope anyway. And then if your answer matches, great, then you're ready to move on to the next step. If not, then you might need to go back and fix something. So the first thing to do in any simplex problem is to first convert them to equations, which means introducing slack variables. So just remember that there are 2 inequalities as constraints in this problem. So we're going to have to introduce 2 slack variables. So the equations are now going to become 3x1 plus x2 plus 3x3 plus s1. And I'm just going to leave some room here, and I'm going to say equals 30, because I just want the variables to line up. The second constraint would tell us that 2x1 plus 2x2 plus 3x3. Now it's going to have its own personal slack variable, s2, and that's going to be equal to 40. I don't write slack variables for the non-negativity constraints. That's kind of an automatic with the simplex method. But remember that we do write the z equation in a special way, because by writing it this way, so it's negative 4x1 minus 3x2 minus 6x3 plus z equals 0, because there's no number. We write it that way because it's easy to spot what we need to do next in the simplex problem, meaning which of the variables do we need to introduce to make z bigger, okay? So the initial simplex tableau will look something like this. So we have our 6 variables, and remember that I always call the one on the right-hand side, the line for the augment, and the line for the column heading. So we just pick off the coefficients, 0, 0, 30, 2, 2, 3, 0, 1, 0, 40. And then our final line, which again, I always write a line to separate it just because the bottom line is the special one. Okay, and just to reiterate, this right here tells you what the initial basic solution is, meaning that x1, x2, and x3 are all 0. S1, S2, and z. So S1 is 30, S2 is 40, z is 0. So remember that we talk about ratios. So we need to figure out what the entering variable is going to be first. So I look for the most negative entry in the bottom row, because that represents what z will change by if we increase. Looks like negative 6 is the most negative entry. So, well, this is interesting. We're going to be dividing the right-hand side by 3s. So basically, whichever one is on the right-hand side is smaller is the winner. So 30 over 3 is 10, and 40 over 3 is 13 and a third. So we'll say row 1 wins, which means that this is my pivot, okay? So we pivot around the first row, meaning I'm going to have to do row operations, keeping the first row each time. It looks like if I take negative R1 and add R2, we get a new row 2. And if I take 2 row 1s and add it to R3, that's going to be the new R3. So at this point, pause the video, try to work out those numbers, because you are just writing out a bunch of numbers and adding some things together. And when you're back, we'll go down to the next line here, and you'll see that that is the next matrix. Okay, whoops, I'm sorry, that's the table. That is the next matrix. And as we can see, it's still not optimal because we still have a negative entry in the bottom row. But that is the only one, which means I know what to do. This means that x2 is going to enter, okay? And I look at ratios again, and again, we're dividing both by 1. Who could ask for anything better, right? The ratio here is going to be 30, and the ratio here is going to be 10, which means the lower ratio wins, which means that's my pivot. So this means that I'm going to be taking the opposite of R2 and adding it to R1 to get a new R1. And I'm going to be taking R1 and R3 to get an R3. So again, at this point, I encourage you to pause the video, work out those row operations, form the new matrix, and here is what you should get. And notice the bottom row, no more negatives, and we'll highlight the columns that correspond to basic variables. We'll say x1 is not part of the party, so that's a shame. We'll say x2 is because it has all but one non-zero, or all but one zero rather. x3 has all but one zero. S1 and S2 are out of the picture now, and it looks like z is always going to be a part of the basic solution. So here's what we have. x1 is equal to 0, so that means we don't require any units of x1 for this problem. We have 1x2 equals 10. We have 3x3 is equal to 20, which means x3 is equal to 20 over 3, or 6 2/3. S1 and S2 are both 0, and it looks like the maximum value of z is 70. So there we have it, our basic solution from the simplex method, 2 iterations. Hopefully this helps you, and I thank you so much for watching.